Okay. Hello. Welcome to the first Unity 2D tutorial. It's me, Victoria, acting Vice President of the Game Builders Club, and let's get started. My goals for this meeting, one is to introduce the Unity layout for anyone who hasn't gotten to see that before. I guess I'm mainly speaking to the VOD at this point, because I believe everyone here has used Unity before. We're going to write a top-down movement script in 2D Unity with point-and-click and WASD control. I'm going to discuss the differences between GetKey and GetButton. Hello! We're just getting started.
Oh, good. Sorry I was a little late. I was heating up a cookie.
It's all good. So, as I was saying, we're going to write a top-down 2D movement script with point-and-click and WASD control. I'm going to discuss the difference between GetKey and GetButton, the difference between GetKey down and just GetKey, and the difference between update and fixed update. So the first thing is open up Unity Hub, and we're going to make a new 2D project. So hit the new 2D, and I'm going to name this tutorial 2D. We're going to create that. And now we have to wait for Unity to actually make this. Which I think I timed it and should take about 1 minute and 40 seconds, but we'll see how long that actually will take. I probably should have just left the base project that I made before open, but it's fine. This might take a while.
If it's not necessary for your presentation, I guess you could just keep going with that while it loads.
Yeah. So I guess I can talk about GetKey versus GetButton. Unity has two main ways of keeping track of player input. The first is GetKey, and the other is GetButton. And there's also GetAccess, but that's related to key and button. Key is forcibly bound to a specific input. So if I say GetKey left arrow, that is only going to work for the left arrow. But if I say GetButton fire 1, that's not a constant, but it's a variable, and I can set fire 1 to be various other buttons, and because of that, it's a lot more popular when getting player input for Unity. I am going to be using GetButton, and I'm also going to be using GetAccess. GetAccess is similar to GetButton, but I can map multiple buttons in different directions. So if I say GetAccess horizontal, I can have buttons for left and right in that one command. So I don't have to write as much code. And then the difference between GetKey down, GetButton down, and just GetButton. GetButton down only will trigger for the frame that you click the button. So if I want to, say, attack using a weapon, and I only want the attack to start its animation on the frame that the button's clicked, I would use GetButton down. But if I want to continue moving forward, I would just use GetButton. And I believe Unity has finally loaded up. So here's the Unity layout. People who have used Unity before, even in 3D, will recognize this is very simple. We've got the scene view, which is very similar to the 3D scene view, except it's a 2D grid. We have the hierarchy over here, which will have all of our game objects. So anything that's physically in the game will appear here. Over here we have the inspector, so if I click on the main camera, I can get a bunch of details for the camera, and this will allow me to change this game object. And down here we have the assets. So if I say want to make a city, and I have like a couple of different buildings that I've already made, they would be down here in the assets. I would make them an asset or a prefab, and then I would be able to drag multiple onto the scene view, and it would be a lot faster than if I were making every individual building by itself. One thing that is different between 3D and 2D is that a 2D object is called a sprite, where in 3D we call it by what 3D prism it is the shape of. So I'm going to go ahead and I'm going to make a circle sprite, and this is going to be our player, so I will name it accordingly. And I will move them off of the main camera. There. And I'm going to make a new C# script down here, and we're going to call this player movement. A C# script is very simple, similar to a Java class in the fact that it will have one class and methods and variables, and is easy to understand if you're familiar with Java programming or other languages. Here we have import statements. If you've been following along with the 3D tutorials, you'll remember that using just means import. And I'm going to make some variables. The first variable that I would like to make, I want to be able to edit the speed of that the player moves at without having to edit the script every single time. So I'm going to make this public. It's going to be a vector 2. In Unity, we have vectors similar to in physics, except instead of having like an angle direction, its only direction is going to be positive or negative. So we'll have like the x component of a vector and the y component of a vector, and those will either be positive or negative. And I want to name this speed. Technically, it should be velocity, but velocity is already taken, and it would get confusing, so we're going to call it speed, and it's going to equal a new vector 2. We'll make it 5. The f just means that it's a float, which means that it's decimal value, which allows it to befit the requirements of a vector 2. Other things that I'm going to want. More vector 2s. I want the target position. So when we're moving, we've got the place that we want to be at. And then we've got the relative position, which is where we are currently. And then movement, which is where what movement we need to go to in order to get to that target position. So I'm going to get rid of the start method because I don't need it. And okay, so in the update method, if input.get key down, I only want this to work for a mouse, because trying to like point and click where you're going to go with a controller or any other input method can get very tedious. So I only want this to work with a mouse, which is why I'm going to use GetKey down. Key code mouse 0. So if the left click, if we have a left click only on the frame that the mouse was clicked, target position is going to equal camera.main screen to world point input dot mouse position. So I just did a lot right there, and I'm going to explain what just happened. So the target position is a vector, and it's where we want to be. So because we're top down, the camera is pointing at the ground. So if we click on a point on the, like where the camera is facing, that's going to be a point on the ground. And screen to world point just allows us to access what the camera's looking at. Input mouse position is where the cursor currently is. Does that make sense? Are there any questions so far? How's things going for you guys?
You might have just explained it, and I might have just zoned out for a second, but what is screen to world point? Like, what does that method do?
So let's go back to here. So I have the game view. So my cursor is on the game view. The camera is pointing directly at the ground because we're assuming that this is a top-down view. So
Okay.
screen to world point is going to get the point on the ground that the cursor is currently pointing at.
Gotcha. Okay.
Okay. Other than that, is everything going well for you guys?
Yeah, it's going well for me.
Yeah, I'm good.
All right. Next, we're going to have if input. Now we're going to work on the WASD controls. So input.GetButton. Get axis. This is a string name. This is how Unity has you interact with variables. You have to insert the string name for it. So horizontal is the name of a default variable. If it's less than 0, so if the left axis, so if I were having a controller and I pushed it to the left, that would be less than 0 because 0 is the midpoint. To the left is negative, to the right is positive. So if it's a negative number, or if I push A, that is determined to be a negative because it's to the left of center. Target position is going to equal. Okay, so when you add a script to Unity, the thing that you've added it to is called the component, and you can get what it's added to. You can get the game object that the component is just by calling game object. Transform is where that currently is, or transform is the game object's thing, and then position is where that transform is, and then X is in the horizontal. Because we're going left, minus, this runs at 60 frames per second, so 60 times speed in the X direction times time dot delta time, which is the time since the last frame. Hopefully that makes sense. It's kind of physics, but hopefully that makes sense. And then for right, it's the same thing, but if it's greater than 0, and then we change all of these x's to y's. So this is just a generic, if I want to go left, then I'm going to say that it's this far left. Speed times time equals the distance that I want to go. And then similar concept for vertical, except this is going to be vertical. So for down, change this to Y. Oh, and this is target position dot X. So the X component of the target position, or the Y component of the target position. Hopefully this all makes sense. And then for going up, oh, and this has to be a plus. Does that make sense to you guys?
Yeah, I think so far.
So why on the horizontal going right are you
Oops. I think his internet. There we go. He's back.
wait, what's happening?
Tyler, I think, just disconnected on accident or something.
Or like glitched out for a second. I'm all good though.
What was your question?
So why whenever you go right are you changing the Y position?
Oh, you're right. That's a mistake on my part.
Okay, cool. I was very confused.
Yes, sorry.
Oh, you're good.
So now, regardless of what input we had, our relative position is going to equal a new vector 2 target position x component minus the game object's transform. It'd be fun if I could type. So we give the x coordinate for that vector 2 and then the y coordinate. And this will give us where we are relative to the target position. And this brings us to another thing that I wanted to discuss. In Unity, there's update, which runs once per frame, and that's fixed. Or that's a set thing. Update will run once per frame. So if you were doing a lot of physics-based things all in update, it'll slow down how often a new frame can happen in order to get everything done. So in order to fix this, Unity has fixed update, and this is where you're supposed to do more physics intensive things. And when I first learned Unity, I was told to put anything that you're doing with physics into fixed update and not into update. So I'm going to put in fixed update. And this is a new method. If the distance that we would go if we were to move, so speed times time dot delta time. So if the speed that we were to go is greater or equal to the distance that we have left to go, I'm going to take the absolute value of this so that way the sign doesn't matter. So math f is a math function dot abs is the absolute value. So we're going to take the absolute value of the relative position x coordinate. So this is just dealing with how far we have left to go. So if we were to move, if that's greater than the distance that we have left to go, we don't want to move. So movement x component is going to equal relative position dot x component. We're good in terms of moving. And if we aren't in good in terms of moving, so else movement x component is going to equal speed x component times the sign, so the direction that we need to go. So math f dot sign of relative x component. So if we don't have to move, like if we were to move and that's too much, don't move. But if we are going to move, move at the speed that we need to go times the direction that we need to go. Does that make sense?
I think so.
Okay. And then we're just going to copy paste this for y and replace everything here with y. The reason why this movement script is so complicated is because I also want to include pointing and clicking moving. If I weren't, then this could be a lot simpler, but I'm working on a point and click game, and therefore I wanted to have a movement script that would incorporate that sort of movement. So after we figured out where we need to move, if we need to move, how much we need to move, get component rigid body 2D. A rigid body is just a thing that we can do physics to. Get component is the thing that we are currently working with. Get its rigid body, and the velocity of that rigid body is going to equal the movement that we need to do. And this is the end of the movement script. Is there anything unclear about the movement script?
One thing, I don't know if it was intentional, and I'm just I don't know something about something, but I saw that you put on line 47, you wrote sign. I don't know if that's supposed to be like a sign like function, or if that's supposed to be spelled with a G.
So relative position is either going to be positive or negative, depending upon where we are relative. So if we want to be in the so currently the game object is here, and if I want to be down here, then I have to move in a negative direction across the screen and a negative direction here. But if I were down here, then I'd have to move in a positive direction to get up here. So mathf.sign is going to get me, it's going to return either a positive number or a negative number, and mathf is going to give me a +1 or -1. So I want to move in that correct direction. Does that explain
Okay, I
that?
see what you mean. Yeah, I just didn't know what the sign method did. So I thought, like, I assumed, like, if it was a math F, if it was in that class, I thought it might be like a sign, like, trigonometry type function.
Yeah, I think it does have sine waves, but we don't need that complicated of stuff. I just want to move in the same direction that the relative position is.
Gotcha, okay.
So now we're going to compile the script. Uh-oh. Oh, we don't have a rigid body on this. So we're going to add a rigid body. Rigid body 2D. Let me make sure that I wrote this right. Oh, rigid body. Body is not capitalized. Okay. Now it compiles, no errors. So now we are going to hit, player does not currently have the movement script, so we're going to add that to here. And I'm going to hit play. And I misspelled horizontal. So I'm going to go back and correctly spell horizontal. And now we should be good. So now if I click here, the rigid body. So rigid bodies have different states that they can be in. We're going to use kinematic, which means that we can use kinematic equations, which are like the basic physics equations, in order to figure out where we're moving to. So we're going to set that rigid body to be kinematic. If I click over here, it goes over here. Click over there, it goes over there. Now I'm going to use my keyboard. You can go up and down, you can go right, you can go left, and we can move around the screen. Ta-da! In just under 30 minutes. Did everyone else have the script work?
I haven't. Sorry, hold on. So you said we needed to add a rigid body 2D to the player, right?
Yes.
And then, hold on, let me double check what I have here. Okay, I didn't put the script on it yet. Hold on.
Yeah, that might help.
If I do that, yeah.
Make sure the rigid body type is kinematic.
Okay. I'm getting the. Hold on. I'm getting the type or namespace rigid body 2D thing could not be found. I'm trying to see.
Did you capitalize the B in rigid body?
Yes.
Don't.
Gotcha.
I made a typo earlier and had to go fix that.
Okay, everything compiled.
And are we able to move?
And yes, I'm good now. Thank you.
Yay. Did it work for everyone else?
Yeah.
Yeah, I'm all good.
Awesome. So that's really all I wanted to cover in this first meeting. Ta-da.
Did you record this if I want to go over like the
I
explanations?
did record it, and I'm also going to include a Google Doc, or I'm going to upload the script in a Word document to the Discord. That way anyone can easily get like you can just copy and paste the script.